Dear students, welcome to the course on Statistical Methods for the Psychological Research Part 2. In this lesson, we are going to learn the statistical decision making regarding retention and rejection of null hypothesis. What are you going to learn in this lesson? Let us look at the learning objectives. After completing this module, you will be able to get clarity on parametric tests and non-parametric tests, understand the role of null hypothesis and alternative hypothesis in the decision making process of testing of hypothesis, and also write the inference in a refined manner. Contents at a glance. In the part 1, we are going to see the overview of any decision making based on research hypothesis by parametric and non-parametric methods. In part 2, the null hypothesis and alternative hypothesis in the mechanism of statistical decision making. In part 3, relevance of retention and rejection of null hypothesis for statistical decision making. Note: parametric methods and parametric tests are interchangeably used. Let us start. We begin with the first part of the lesson, in which you will learn the overview of any decision making based on research hypothesis by parametric and non-parametric methods. Parametric tests concept. These tests are concerned with testing or estimating the parameters of the population. Since the testing of the hypothesis involves parameter, it is called parametric test. Parametric test assumptions. Parent population follows a normal distribution. Measurement in interval scale. Sample size is large. Remarks: parametric tests are more powerful when the above conditions are satisfied. These conditions are strong in nature. If any of these conditions get violated, the parametric test becomes inappropriate. In such cases, one should opt for the non-parametric test. Non-parametric methods. Non-parametric methods were specially developed to be used in cases where the researcher is not familiar with parameters of the variable of interest in the population, hence the name non-parametric. It only makes weak assumptions about the form of the population. It is also called distribution free method because, in more technical terms, non-parametric methods do not rely on the estimation of parameters such as the mean or standard deviation for describing the distribution of the variable of interest in the population. Therefore, these methods are sometimes called, and more appropriately, parameter free methods or distribution free methods. Environmental need for conducting non-parametric tests. Sample observations are independent. The variable under study is continuous. Probability function is continuous. Lower order moments exist. Assumptions of non-parametric tests. Nothing is known about the normality of the variable, or the data follows a non-normal distribution. Data of low quality or ordinal scale. Sample size is very small. Let us discuss each assumption in detail. Now we will move on to the assumption of normality. Normality. Parametric tests can be used if the variables are normally distributed. We do not know for sure whether many variables of interest follow normal distribution. There are situations where problems follow non-normal distribution. Non-normal situations. Examples: is income distributed normally in the population? It is probably not. The incidence rates of rare diseases are not distributed normally in the population. The number of car accidents is also not normally distributed. So, opt for non-parametric tests in the case of non-normal data. Next is measurement scale. Most common statistical techniques use the numerical variables such as height, weight, blood pressure, etc. The underlying measurements are at least of interval scale. The variables may sometimes be measured in an ordinal scale rather than precise measurements of an interval scale. For example, how is the taste of the coffee? The answer may be very good, good, average, poor and very poor. Here, the response is a text variable or string variable and it is in order, ascending or descending. The response is in ordinal scale. In such cases, choose non-parametric tests. It also depends on sample size. Another factor that often limits the applicability of parametric tests depend on the sample size small n. As long as the sample size small n is large enough, that is more than 100 observation, one can assume that the sampling distribution is normal, even if you are not sure that the distribution of the variable in the population is normal. However, if the sample size n less than 30, the parametric test can be used only when we are sure that the variable is normally distributed. Otherwise, opt for a non-parametric test. Furthermore, there is no way to test the normality assumption if the sample size is very small, say around 10. Comparison between parametric and non-parametric tests. Non-parametric tests are less efficient than their parametric counterparts. When the data set is large, that is n greater than 100, using non-parametric statistics often makes little sense. Parametric methods are usually much more sensitive, that is, have more statistical power, and in most cases appropriate for large samples than non-parametric tests. Brief overview of non-parametric procedures. There is at least one non-parametric equivalent for each parametric general type of test. That means, corresponding to every parametric test, there is a non-parametric test. These tests generally fall into the following categories: tests of differences between groups, that is called independent samples; tests of difference between variables, this is called dependent samples; tests of relationship between variables. Comparison, parametric, non-parametric. When you have to compare the mean value of two samples for some variable of interest, you would use the t-test for independent samples. Corresponding to that, in non-parametric, we are having the tests, namely Wald-Wolfitz run test, Mann-Whitney U-test, the Kolmogorov-Smirnov two-sample test. If you have multiple groups, you would use analysis of variance. Counter to that, in non-parametric, equivalent method is Kruskal-Wallis analysis of ranks and the median test. It is useful whenever the usual assumptions underlying the analysis of variance cannot be met. Example, after teaching a computer course for 2 weeks, an instructor wanted to know if students had gained a significant amount of computer operation knowledge through his coaching. He took a pre-test before the coaching and a post-test after the conclusion of the coaching and obtained the test scores. He set alpha equal to 0.05 as the level of significance. Problem. Now, this is the problem. In this problem, you can see we are having only 10 pairs of values, 10 pairs of values, not 20. because it is pairs, therefore 10 pairs of values. Sample size is less than 10, therefore one should go for non-parametric test. Students, I hope you understood all the concepts. We will continue in the next video. Thank you.